So once again, this is in the form y is equal to a plus bx. Okay, the a part is the -1 and the b part is the 5/2. Okay, so excuse me, so this line intersects at -1, so here's a point on the line here, intersects the y-axis at -1, and its slope is 5/2, which is the same as 2.5. So if I come out 1 unit, I'm going to go up 2 units and a half, which is going to bring me up to approximately here. So that's 2 points now on the line. So this line now looks like something like this here. Okay, this is the line, but we're interested in values, okay, that are less than or equal to 2. So maybe what we should do is we should choose a couple of values and see what we get. So let's just choose a value over here. Let's say we choose this particular value here, which is 1, 2, 3, 4 and 1. So it's 4 and 1, and let's see what this evaluates to. So it's 5 times 4 minus 2 times 1. That's going to give us 20 minus 2, which gives us 18. Okay, so that gives us 18. I'm writing that when I say that. Yeah, that gives us 18. And 18 is not less than or equal to 2. Okay, so 18 is not less than or equal to 2. So we know that this point ain't on that side of the line. Okay, so what we need to do is, if we just check on this side of the line, which it must be, okay, so let's just check another point. Well, actually, let's just check this point, let's say here, which is -1, 4. So we check -1, 4, we get 5 times -1 minus 2 times 4. Okay, well, that gives us -5, and that gives us -8, which gives us -13, which is less than or equal to 2. So it's actually this side of the plane. So this line, this plane now, okay, represents over in this particular direction here. Okay, so the area of the plane that matches, if both of these were constraints on our system, okay, and if we had also more constraints, but if both of these were constraints on our initial system, the area of the plane that we would be interested in, is things that are to the left of this line here. Okay, this line, and things that are below this line here. So what we'd be interested in is this particular area in here. Now, linear programming problems, okay, typically have other constraints. For example, they might say x is greater than 0 and y is greater than 0. Okay, in which case we'd be talking about the x values have to be bigger than 0, so it's over here. Okay, and the y values have to be bigger than 0, so it's up here. So actually what we're really talking about is we'd be talking about this area in here would be the, let's say, the feasible region, if that's what we were talking about. Okay, let's just have a look at some other important lines. Okay, so let's say if I was looking at the line, let's say the line where x is less than or equal to, let's say, for argument's sake, less than or equal to 5. Okay, well, let's have a look at when x is equal to 5. Where is x equal to 5? There's 4, here's 5. There's where x is equal to 5. Actually, all along here we have that x equals 5, and we're interested in values of x being less than or equal to 5. So from an inequality perspective, this is talking about this part of the plane here. Okay, that's important. Okay, let's see what else we could have. Let's say if we had, well, what about when y is greater than or equal to 5? Well, where is y equal to 5? There's 4, here's 5, so y is equal to 5 right here, and also across in this region. Okay, across in this region, so it's actually greater than or equal to 5 everywhere where it's greater than or equal to 5 is up here, if that makes sense. Yeah. Okay, so there's some important lines for us. Other important lines are probably where let's say where x is equal to y. Okay, x is equal to y is, well, 0, 0, 1, 1, 2, 2. So it's the line that goes through the origin that makes an angle of 45 degrees. Here's this line here. Okay, x is equal to y. If we were interested in the values where x is greater than or equal to y, so what values of x are bigger than y? Okay, well, the values of x that are bigger than y are all the values. Well, let's choose a point. Well, here's a value 4, 1. The x is bigger than the y here, so we're talking about in relation to that inequality we're talking about, this particular region over here. Okay. Now there's a lot of lines mapped here. If you go back to the start, you'll see this being constructed gradually. Okay, but the important thing here is that this just introduction here was just, we're just talking about inequalities, and that the inequalities represent half planes with respect to the overall xy plane, and from a linear programming perspective, we're interested in where these planes, let's say, intersect, where the planes match all of the particular constraints and conditions. Okay, guys, the next example is actually going to take this a little bit further, and we're going to look at a specific example of where an investor has an amount of money to invest, and they have two options, bond A and bond B, and they need to choose which bond to take based off a set of constraints. So, guys, once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. I hope that this video was intuitive, and more importantly, I hope that was helpful for you, and thanks for watching. Okay, bye bye.